Stop for a moment and think of this. Are we alone in the universe? It's perhaps the biggest question we've ever asked.
It's not crazy to imagine that some hugely superhuman civilization exists out there. They may have been watching the Earth for millions of years.
After a long and distinguished career at the forefront of cosmology, the Astronomer Royal, Martin Rees, has taken up the hunt for extraterrestrials.
Absence of evidence is not evidence of absence.
Now, with the help of the BBC's archive,
we can't prove that bug-eyed monsters don't exist.
Martin's going to take us into his world. You might think hunting for aliens is just science fiction. You'd be wrong.
Quite a sight, wasn't it, sir?
A sight I'd rather not be seeing.
It's a vibrant frontier of modern science. Where fierce debates rage.
It's possible that we are 1 trillion to 1 fluke.
I think that's an over-hasty conclusion.
By exploring opposing views.
A lot of sloppy thinking is quite accepted about alien intelligence, and I think that is a problem.
We'll travel to the limits of our understanding about the universe and our place in it. It's a journey that, for Martin, leads to an extraordinary conclusion. Our idea of what an alien will be is all wrong. It's not organic beings we should be looking for. It's machines. On July 20th, 2015, Professor Martin Rees joined some of the greatest minds in science at the Royal Society. They were launching a £70 million research program. The aim, finding intelligent life in the universe.
It's a huge gamble, of course. No one would count on success, but the payoff would be so colossal.
The team are using some of the world's biggest telescopes to hunt for a signal. It's our best chance yet of finding aliens.
Stakes are so high, and that's why I think there's more interest and more focus, certainly among mainstream scientists, on this topic than there ever was in the past.
And we are gradually edging closer to answers.
With at least 2 billion stars in our universe, somewhere in deep space there are probably planets with civilizations built by living creatures.
As our knowledge of the universe has increased, so has our understanding of who or what might be living out there.
Hello!
3, 2, 0, and
Aliens
lift off
have gone
for the
mainstream.
final launch of Endeavour, expanding our knowledge, expanding our lives.
That's why scientists like Martin, more famous for researching the Big Bang and black holes, have joined the hunt for extraterrestrials.
Are we alone, or is there life elsewhere, especially fascinating to us today, because for the first time we have a real chance of answering it, because of the advances in technology and in our understanding of life.
But first there's a problem. Before we can explore Martin's ideas on aliens, there's one question all those who look for ET must face. It's a question famously posed in the most unlikely of settings. Los Alamos, birthplace of the bomb. The year is 1950, and Enrico Fermi, one of the architects of the atomic age, is taking a break.
Fermi was having lunch with some colleagues. They were talking about the existence or otherwise of aliens. And midway through the lunch, Fermi just stopped and said, "Where is everybody?"
Where indeed. Fermi's point was that if there are lots of alien civilizations out there, why haven't we found any? It may seem a simple observation, but for physicist Stephen Webb, it casts doubt on the idea that we have any cosmic company at all. Because Fermi did more than just ask the question. Like all good scientists, he did a spot of maths.
And what he did was run through the numbers, looked at the number of stars in the galaxy, number of planets. He made an estimate of how many extraterrestrial civilizations should be out there, and he came to a large number.
Given the huge scale of the galaxy, Fermi calculated that there should be loads of alien civilizations out there. What's more, he reasoned that many of them would be far more advanced than our own.
There are many stars which are quite a bit older than the Earth. Indeed, in our galaxy there are stars 2 or 3 billion years older than the Sun, which could perfectly well have evolved planets, rather like happened here on Earth. And of course you then have to ask, if that were the case, then the life on those alien planets would have had a head start.
Fermi's conclusion was that aliens should easily have colonized the galaxy by now, several times over. In short, there should be spacefaring civilizations everywhere.
So Fermi realized that there's something paradoxical about this. We expect to see them, and we don't.
It's called, guess what? The Fermi paradox. And for some, it leads to a stunning conclusion.
It's a surprise to me. I would expect, if they exist, that we would see them, we would hear from them. It could build large structures. We could see exhaust from antimatter rockets. We could see artificial lines in a star's spectrum that they've put there. The conclusion that I would draw from that is that we are alone. And that's a really, really sad thought.
I think that's an over-hasty conclusion, because we've no idea what variety the life out there might take. If there are aliens out there, then they're likely to be extremely different from us, in my opinion, because there could be all kinds of intelligence which would not manifest itself in any way that we can yet detect.
Indeed, Martin's not ruling out the possibility that we may someday find evidence that alien civilizations have visited our solar system.
You can certainly imagine scenarios where some alien civilization sent out lots of probes, and some of them came to our solar system, and therefore we should keep our eyes open for any artifacts that we might come across orbiting in space or even on one of the planets, which could be evidence of some kind of external civilization.
It's a long shot, though. And until we stumble across a space probe lurking in the asteroid belt, we need more solid foundations for our hunt. Which means starting with something much simpler, because intelligence isn't everything. Consider bacteria, simple single-celled organisms, superficially nothing special. But these humble life forms could hold the key to understanding how common life is in the universe. And if it's just alien bacteria we're looking for, it might be right under our noses. For centuries, Mars was the prime candidate for alien life in our solar system.
In fact, in about 1900, there was a French foundation that set up a prize of 100,000 French francs for the first detection of extraterrestrial intelligence. And in the rules for that prize, they excluded Mars, because it was thought too easy to detect life on Mars.
We've just had some amazing photographs sent back by the American probe to Mars, Mariner 6.
NASA's Mariner probes first took us to Mars, first in 1965, then again in '69.
You can see, sir, some of the dark areas, which may be vegetation, and at the bottom you can see the white polar cap, which has always been thought to be due to some kind of icy or frosty deposit.
But close-up pictures revealed a barren world. Hopes of Martian life began to slip away.
Well, primitive life there may be. I don't even think so. Intelligent life, certainly not.
So in other words, you rather think that Mars is a dead planet?
Absolutely dead as a dodo.
It certainly looked as dead as a dodo.
There's nothing, there's not even any desert scrub clinging to the edge of a cliff. There's nothing. It's completely bare.
This is Professor Monica Grady. She's one of a growing number of scientists who believe that, despite appearances, our solar system may yet turn out to be home to alien life.
15 or so years ago, you were regarded as, at best, fringe, at worst, lunatic, if you were going to study these sort of...
0 and lift off for the final launch.
Probe after probe visited the planets in turn. Scientists had grown increasingly confident that Earth was unique in our solar system in being home to life. But for Professor Grady, this just doesn't make sense.
The ingredients of life are really, really simple. Basically, hydrogen, carbon, oxygen and nitrogen. And they are the most abundant elements in the solar system, the most abundant elements in the universe. So there's no reason why life could not, should not have got going in places beyond the Earth, because it's simply physics and chemistry.
But that raises a big question. How did physics and chemistry turn into biology? How was life on Earth first created? We know that all life on Earth is related. We share DNA not just with monkeys, but with all the animals and plant life we see. Go back far enough, and all living things share the same common ancestor, a single cell. What nobody knows yet is where that first cell came from.
The origin of life, everyone has known for a century, is a key problem in science. At present, when we only know about life in one place, we can't rule out the possibility that the odds against life emerging are zillions to 1.
So do we know anything about how easy it was for that first cell to form? Well, there is one thing. On our planet, it happened very early. 4.5 billion years ago, the Earth was formed from a collapsing cloud of gas and dust. It was a violent event. Volcanoes pumped out a toxic atmosphere, and the young planet was bombarded by asteroids. Yet, in this literal hell on Earth, chemistry turned into biology. Almost as soon as the planet had a solid crust, life began.
I suspect that we will find that simple life in some form is something which can form fairly readily, given the amount of space and time on a young planet.
Biology's early emergence on Earth offers hope that life might have formed elsewhere in our solar system. And possibly not too far away, because our next-door neighbor had a remarkably similar early life.
Mars was made at the same time as the Earth was made, so roughly 4.5 billion years ago, made from the same materials by the same processes. It did have active volcanoes, it had rain, it had water flowing over its surface. So for the first billion years of its life, it was like the Earth. And in the first billion years of Earth, life got going.
But if life did get going on Mars, it would have soon found it tough going. Mars cooled down fast. Its small size meant it couldn't retain its internal heat. And with no magnetic field, much of its atmosphere was lost to space. Could life still be there now? Until recently, most people would have said no. But the more we learn about simple bacterial life of the kind that might have formed on Mars, the more we realize that it's more robust than we ever thought possible.
If you think of the range of environments in which people can survive, you know, some of us get really sunburnt if we go, you know, out into the garden and the temperature's above about 25 degrees C. But bacteria is everywhere. I mean, you know, absolutely everywhere. Deep inside nuclear reactors, deep below the surface of the Earth, in boiling hot water, frozen in Antarctica. It's all over the place. These sort of microorganisms are called extremophiles. They love being at these extremes.
In fact, they're so hardy, scientists decided to test them in the ultimate extreme environment. Space.
D-minus 10, 9, 8, go from 8 to start. 7, 6.
On February 7th, 2008, the Space Shuttle Atlantis blasted off with a surprising payload.
Take it from the top. 3, 2, final launch of the depth to the space. Expanding our knowledge. Expanding our
These cliffs are surprisingly harsh place. When they're not being hit with a hammer, they're being blasted by sun and salty water. So a sample of these hardy bacteria spent 553 days outside the International Space Station. Scorched by cosmic rays and subjected to extreme shifts in temperatures. When they returned, something was still alive. Bacteria called OU20. Life could survive in space.
Study of extremophiles has shown that it can exist over a wider range of conditions than people had thought previously, and that of course is something which is good news in the sense that it widens the range of possible locations for life if we think about the wider galaxy.
And for Monica Grady, these hardy organisms raise a startling possibility. If bacteria did form on Mars, as they did on Earth, then maybe they're still there today.
If you look at Antarctica from the air, you see a barren and desolate place. You don't see any trees or vegetation. When you get up close to some of the rocks and break them open, you can see that there is a colony in there, a colony of microorganisms called cryptoendoliths hidden inside the rock. Maybe they're there on Mars.
And we might not be too far off finding out if it's true. Right now, the European ExoMars probe is en route to the Red Planet, where it will scan for biological signatures. It's then hoped a rover will follow in 2019, drilling for signs of life in the Martian soil. And if we find Mars has at any time played host to bacteria, it will be a game changer.
As soon as we find a trace of some sort of biology, we can be almost certain, almost absolutely 100% certain maybe, that there is going to be physics turning to chemistry, turning to biology on planets around stars in our own galaxy and in many, many, many other galaxies.
I would say that finding evidence for life elsewhere of independent origin would be a huge discovery, one of the great discoveries of the century if it happened, because it would have these implications about the likelihood of life existing throughout the entire universe.
These days, most scientists think it's likely that we do live in a universe teeming with simple life. But a few cells in a petri dish aren't what most people think of when they imagine E.T. So here's the next big question. If there is primitive life out there, what are the chances it could have evolved into something we might truly call an alien? Again, our Earth offers the only example of evolution that we can use as evidence. But this time, things don't look so hopeful.
All we know from the history of life on Earth is that it took a long time to get from single-cell life to the next stage, multicellular one. And that, of course, suggests that that might involve some rather improbable change.
For 2 billion years, the Earth was home only to simple organisms like bacteria. In short, slime. But then, something happened. It's thought one primitive cell swallowed another, and the two began working together. It was the first step on the path to more and more complex organisms, and the huge diversity we see today.
What we don't know is just how many of the specific features of the Earth were crucial in order to allow life to proceed through its stages of emergent complexity. And that therefore means we don't know for sure how likely it would be that life would develop complexity on other planets. This is a big debate.
For some, the late emergence of complex life on Earth points to it being a very rare event indeed.
There's a hypothesis, it's called the rare Earth hypothesis, that suggests that there's something special about Earth.
This rare Earth hypothesis claims that an extraordinary, once-in-a-galaxy run of good luck led to the evolution of our planet's rich and diverse life. If true, other worlds wouldn't make it past slime. And slime isn't well suited to interstellar travel. Some conditions that are part of the rare Earth hypothesis don't sound too rare.
We're looking for a star that's been stable for billions of years. We're looking for a rocky planet with water on there.
But some are trickier. One, in particular, takes us back once again to our Earth's violent formation, and a day that was responsible for much of what makes Earth so special. And yet it was just a chance event. It's believed the Earth once had a twin, a Mars-sized planet named Theia, born in a similar orbit. The result? Well, be grateful you weren't there. Theia was destroyed in the collision. But the debris coalesced, forming our planet's traveling companion, the Moon. It's true moons aren't rare, but our Moon is huge compared to the Earth. And this may have been vital for complex life. Because our Moon doesn't just give us tides.
The Moon plays a key role in stabilizing the Earth's axial tilt, which gives rise to the nice, pleasant seasons that we enjoy. there's the possibility that the existence of the moon has helped a long 4 billion year period of clement weather.
Without the moon, some believe our planet's tilt would have been unstable. Some years our seasons would be unbearably hot and long. Other years wouldn't have seasons at all. Such an unstable climate might have meant that complex life never got out of the starting blocks. Because evolution relies on small changes from one generation to the next. If that change is useful, the creature is more likely to survive. But if there were extreme swings in climate, so extreme that at times there was no liquid water, an adaptation that's useful one year may be wiped out the next. No long-term stability, no natural selection. And it's not just the moon. There are many other examples of our planet's apparent good fortune.
Earth has a system of plate tectonics. Plate tectonics is important for stabilizing Earth's temperature.
The movements of the vast network of rigid plates that make up our planet's surface create massive volcanic eruptions, recycling carbon dioxide into the atmosphere. Today we think of it as a nasty greenhouse gas, but throughout the Earth's long history, carbon dioxide has helped regulate our planet's temperature, so complex life can survive. The rare earth hypothesis also suggests that we have a lot to thank Jupiter for. The gas giant's huge gravitational pull might capture asteroids that would otherwise be on a collision course with Earth. It's hard to evolve if icy rocks constantly rain down on you from above. The special conditions that led to complex life on Earth go on and on. And maybe there's only one conclusion.
It's possible that we are a 1,000,000,000,000 fluke, that there's some combination of factors that make Earth special.
My view is that these ideas of the so-called very rare Earth are rather oversold, and that we've learned that life can exist in a variety of contexts in the Earth, and our observations are limited, our imagination's even more limited. So my view is that we should not be put off or not take too seriously the fact that our particular evolutionary track here on Earth depended on some special conditions.
There's another, more practical reason that the rare Earth hypothesis might be overplayed. Perhaps it underestimates the sheer number and variety of other worlds in our galaxy.
We've learnt, actually just in the last few years, a great deal about our universe that makes the night sky far more interesting. 100 years ago, people thought that planets were very rare around other stars. No one had found any direct evidence for a planet until 20 years ago.
It was once thought that detecting planets around other stars would be impossible. They were just too small and too far away. But in 1995, the impossible happened. Two Swiss scientists, Didier Queloz and Michel Mayor, were monitoring the positions of some 140 stars. But one of these stars was a puzzle. On closer inspection, they realized the sun-like star, 51 Pegasi, was on the move.
In fact, the first reaction that you have at that time is, oh, something is wrong with the experiment. And you observe it again the day after and the day after, and then it was more and more awful because it was moving every day. and you say, all right, there is really a big problem with the experiment.
Each time they looked, the movement had changed. Gradually, a pattern emerged. The star was wobbling around a point. This could mean only one thing. 51 Peg was not alone. It was being pushed and pulled by the gravity of a smaller body we couldn't see. This was the first planet we'd found orbiting another star, a huge moment in our hunt for worlds aliens might call home.
It was a completely crazy time with call from papers, from television, from radio, from all the world, and email, 100 email per day or something like this. It was absolutely a completely time where we have no possibility to work at all.
This planet was too large and too hot to be home to life. But we've got better at this planet hunting lark. Over time, we've found smaller planets, further out from their parent stars. Until eventually, in April 2007, Gliese 581c was discovered. And scientists thought it just might be capable of supporting life.
European astronomers have spotted a new planet outside our solar system which closely resembles the planet Earth.
Every time somebody finds an Earth-like planet, the probability that there is life somewhere else in the universe goes up a bit.
This latest find has set the world of astronomy alight.
In the last few years, more and more planets have been found. Many in the so-called Goldilocks zone, not too hot and not too cold for liquid water. The more we look, the more we realize that Earth-like planets are all over the place.
The universe which we now perceive is far vaster than it was perceived to be in earlier centuries. In our galaxy, there are probably literally 1 billion planets like the Earth.
We've seen that it's possible simple life is common in the universe. Complex life could be trickier. Conditions need to be just right. But the sheer number of planets we've discovered just in our own galaxy suggests that such conditions could be surprisingly common. But there's one further leap that needs to happen before we can hope to make contact with aliens. The leap to intelligence. And we're not talking about the ability to bash a few rocks together. We need civilizations that can communicate across the vastness of space. So is it possible to predict how common intelligent civilizations are in the galaxy? Fortunately, thanks to astronomer Frank Drake, we have an equation designed to tell us just that.
And in fact, this is our number n, the number of technical civilizations in the galaxy.
The challenge is to give each term a number and simply multiply them together.
Into the now famous or infamous Drake equation goes everything from astrophysics through evolutionary biology to whatever it is that governs the lifetime of a detectable civilization. Not surprisingly, no one solved it yet, but anyone can have a go. It's almost a game the whole family could play.
Get the numbers right and bingo, you know how many communicating civilizations are likely to be out there. So in 1981, BBC Horizon locked some of the brightest minds in NASA in a room together and asked them to come up with a solution.
Team captain today is John Wolfe.
I think it was Frank Drake himself who said that this is a Rather nice way of fitting a great deal of ignorance into a very small space.
Some of Drake's variables we know reasonably well. We know how often stars form, and these days we can have a good stab at how many stars have planets.
Seem to have more consensus,
easy, wasn't it?
more consensus there than anywhere. Quickly.
This may reflect the fact that we're moving to the area that we know least about.
It's the later terms we know less well. But scientists don't mind guesswork, provided it's educated guesswork. And when it comes to asking if life would eventually evolve intelligence, the NASA scientists were actually quite confident.
It's very natural, I think, to argue that intelligence with the survival capability that's inherent in it will also follow. I think that's the usual argument for F sub I being unity.
In fact, the first guy to get smart is the one that dominates the planet.
That's right.
Thank God we were first.
They were equally confident that intelligent life would go on to develop the ability to communicate across space.
Put it up there. That's good enough. Wait till we get to L.
You might think this would mean that intelligent civilizations are 10 a penny, but the final term, L, causes the team some problems. It asks us to estimate the lifetime of communicating civilizations.
It soon emerges they're going to chicken out of reaching a conclusion.
So if we were to take that lower value of 100, that says that N is...
The average lifetime lies somewhere between a few hundred years and a few billion. So the number of civilizations in the galaxy now is somewhere between a few tens and a few 100 million.
A few tens to a few 100 million isn't the most exact solution. The term L is so hard to estimate because it forces us to ask a very difficult and rather uncomfortable question. How long do intelligent civilizations like ours last?
Of course, we know that here on Earth, the amount of time we've had any kind of civilization is a few thousand years, and that is only 1/1,000,000th of the age of the Earth. So it's just a sliver, and we don't know how long it will last in future.
If civilizations last for only a few hundred years, then the window of communication is impossibly small. There are actually people trying to figure out just how long advanced civilizations might last. Dr. Anders Sandberg works at the Future of Humanity Institute in Oxford University. It's his job to think about the myriad ways a society could destroy itself.
So we humans have mastered this planet, but in the process, of course, we caused a lot of extinctions of animals, and now we're changing the climate, and we're developing bioweapons in the lab that could kill a lot of people. So we're obviously a danger to ourselves. So it might be that sufficiently powerful technologies mean that a civilization will start blowing itself up or poisoning itself in a very effective way.
And let's not forget, advanced aliens might have technologies that we haven't even dreamt of yet.
The basic problem here is that powerful technology is dangerous. And advanced civilization will have a lot of powerful technologies at their disposal.
Quite a sight, wasn't it, sir?
A sight I'd rather not be seeing.
The truth is, we don't know whether intelligence might ultimately be fatal. So we can't know how many civilizations out there could hold up their end of the conversation. And this makes our hunt all the more important. Because if we find advanced aliens, we'll know for certain that societies can survive their own powerful technologies. So how do you go about finding extraterrestrial intelligence?
What we know is that here on Earth, life has evolved to a kind of intelligence that can develop a technological civilization which would make our activities detectable in principle to an alien with a big telescope. So we've learned that we have become more conspicuous, and that an alien watching the Earth would realize that something special had happened in the last few centuries.
Humans have existed for about 200,000 years, but for most of this time, alien astronomers looking at the Earth would see little to suggest there's anything intelligent down here. In fact, it wasn't until 80 years ago that we really screamed our presence to the galaxy, when we began leaking radio and television signals into space. So if the Earth's first sign of intelligence was our making a racket in the radio spectrum, it's only natural to wonder whether intelligent aliens would be doing the same.
Listen. Sound picked up from outer space by radio telescope for some earthly usage still unknown.
The 50s and 60s saw the construction of radio telescopes so sensitive they could tune into signals from the other side of the galaxy. The hunt was on.
Into such a dish one day could come a signal that would reveal the existence of other creatures unimaginably more intelligent than we are.
It was the radio astronomers who were the first to talk about doing serious searches for artificial signals. And the first effort to do this was pioneered by Frank Drake, who is one of the pioneers of this subject and is still one of the leaders of it today.
Before he wrote his frustrating equation, Frank Drake gave birth to SETI, the search for extraterrestrial intelligence.
We used the 85-foot telescope there and a special, very sensitive receiver, which was especially designed to detect intelligent signals rather than the natural emissions radio astronomers normally study.
For the first time, man made a serious attempt to determine whether he was alone in the universe.
We searched for 2 months and studied the two nearest stars which are like the Sun, the stars Tau Ceti and Epsilon Eridani.
For all we knew then, every star had intelligent civilizations in orbit, pumping out radio waves. And just a few days into the search, it looked like that might be the case.
At one point we had a very exciting recording on our tape recorder.
The telescope picked up a short but clearly artificial signal on a frequency protected for radio astronomy. The news leaked out. Journalists started to call up, asking if Drake had found an alien civilization on his first go. Could it really be so easy? 10 days later, and the signal came again. Only this time, the source was clear.
Analysis of this and further study of the signal showed that it had come not from space, but rather from a radio station on Earth.
What Drake had discovered was a top-secret U-2 spy plane flying at high altitude.
I'm sorry.
Not quite the distant signal they were hoping for.
After 300 hours of searching, we concluded that our two target stars, Tau Ceti and Epsilon Eridani, had produced no evidence whatsoever for extraterrestrial radio signals.
It was an inauspicious start to our search. No aliens and a fourth signal. But Frank had paved the way. Systematic searches were now possible. More followed. This time scanning thousands of stars.
I see even 2 glitches on this one.
Yeah, pretty unfortunate.
Probably a car going by or the equipment screwed up or something like that.
Whilst we wait for first contact, we have time to consider another question. Who, or indeed what, might we make contact with? A clue to what we might find lies in our own species' future.
It's taken us a few hundred years to evolve our technological civilization. It's changing very fast. And if we think of what's going to happen in the next century, one scenario is that intelligence of the organic kind may be near its limit with humans.
We like to think we're a pretty smart species. As evidence, we might point to our technological achievements. Our computers and sophisticated artificial intelligence, perhaps. But maybe they're getting so good that our robot servants will soon be our robot masters.
The future intelligence in our solar system may lie not with organic life on Earth, but with these entities which are electronic rather than chemical, like what goes on in our human skulls.
Martin's point is that it looks like it won't be long before the robots here on Earth are much smarter than we are. And if this happens, it's likely that their culture will dominate ours. But what does this have to do with aliens? Well, if it does turn out that humanity's role is to act as the midwives to a new robotic superspecies, there's no reason other worlds won't have followed a similar path.
If there were another planet on which evolution had tracked what happens on Earth, then there are two options. Either it hasn't yet got to the stage of emergent intelligence, we see no signal from it, or it's got to the stage when the machines have taken over. What is most unlikely is that we would find another planet whose evolution was so synchronized with ours that we would observe it in the just few centuries when the dominant feature is organic intelligence and civilization.
If Martin's right, in our first encounter with aliens we might be dealing not with organisms, but with super advanced artificial intelligences. One thing's for sure. If we encounter such beings, they would be unlike anything we've ever seen before.
We are thinking about the possibility of entities who may be able to grasp concepts which are as far beyond the human mind as quantum theory is beyond a monkey's mind.
So are these entities out there? We've seen how scientists think our universe might be teeming with life. And perhaps somewhere it's evolved and gone on to do things that dwarf our own achievements. But we've also seen that there are an awful lot of barriers to intelligent civilizations. It feels like we're on the brink. There is a huge truth to discover. A truth that tells us not just what's out there, but what might lie ahead for us down here on Earth. Whatever we find, one thing is certain. The answer will change our understanding of our place in the universe forever.
Were it the case that the origin of life or the origin of intelligent life were an extremely rare phenomenon, so that we were in a sense unique or unique in our galaxy, then our fate matters not just to us, but maybe in a sense of cosmic importance, and the greening of the galaxy could then start with us. But of course, if there were life everywhere in our galaxy, as there may well be, it would in a sense force us to be somewhat more cosmically modest. But the upside would be that instead of it just being lifeless planets and stars orbiting around in the galaxy, we would realize that we are in a far more interesting cosmos than one in which life is limited to one place.